Okay, Monday, September 23rd. Today we did a system of equations, or we introduced system of equations. Some of you might be watching this because you were testing during class today. We didn't cover a whole lot of new stuff. We actually just kind of went over old stuff to make sure that we're good at it, because we need to be good at it if we're going to be good at systems, okay? So we didn't actually learn how to solve systems. We just learned what systems were and some of the things that we need to know in order to solve systems. So the basics, the fundamentals, if you will. So this first slide, explains what a system is. A system of equations is a set of equations that are worked together. Systems are a collection of lines graphed on the same coordinate plane, okay? So a lot of times, this is actually a very practical use of math. Systems of equations, also kind of referred to as linear algebra once you get to like college level stuff. Really useful, especially for businesses when they're trying to measure out or analyze cost and revenue. How much does it cost to make stuff and how much revenue can I make from it? And I can compare those things and try to find a good balance so that I can make the most money. It gets really complicated and way more complex than the systems we're going to use, but just know that this is the basics of something that they would use in economics and stuff like that. So it has plenty more applications, but we'll look at a few word problems that are, of course, it's typical high school word problems. But yeah, we're definitely not going to get into the fancy stuff that they would do in actual business world, but this is the basics of systems. So a system, what does it look like? It looks like this graph here. Okay, basically, you've got two lines on the same graph, and that's a system. Now, it doesn't have to be a line. You might have a parabola, you might have different, it doesn't have to be a straight line. You could have any type of function on here. But it's more than one function or more than one line graphed on a coordinate plane. Now, what is a solution to a system? A solution is the set of points that the two or more equations all have in common. Okay, on the graph, these points are the points of intersection. So, based on this picture, let me zoom in for you. Okay, I can do that. Based on this picture, there's only one point that is on both of those lines. There's only one point that's on the blue line and the red line. And that is, of course, the point where they cross. That point right there is the only point that is on the red line. The red line goes right through it. And it's on the blue line as well. The blue line goes right through it. So that is a solution to our system. A solution is going to be a point that is on every line, is a part of every equation in that system. So there's a lot of points on this blue line, and there's a lot of points on this red line, but the only solution is the point that's on both. The one point that is on both, and that's right here, right where the two lines cross. Okay, so now we're going to do, again, we're not going to solve systems, but we're going to practice a few. Right here, we're going to check these solutions. So what you're looking at here is that is a system, okay? That is two lines. The first one is a line on a graph, and the second one is a line on a graph. These are both lines, okay? Here on the left, I have a point. So we're going to check to see if this point is the solution to our system. Now, to be the solution to our system, that point has to be on both lines. This point has to be on the first line and the second line, okay? If that point is on both lines, then that must mean that point is at that intersection. If the point is on both lines, it means it's at the intersection. Now, how do we check? How do we check to know if that point is on both lines? Well, we know that the point is an x-y ordered pair. I have the systems with x and y in it, so I can just plug in the x and the y and see if they fit or if they don't. So we're going to take the first equation, 2 fifths, and we're going to times it by 5. We're going to plug in 5. 2 fifths x is 2 fifths times 5. Minus y, we're going to plug 2 in for y, right? I'm just plugging in my x and my y value from my point, and I'm just going to see if they fit, right? Equals 0. So let's see what this comes out to. So Now, notice, I know we get fraction here, but it's not an overly complicated fraction because what we're doing is we're dividing by 5 and multiplying by 5. So those are inverses of each other, meaning that those two 5s are just going to cancel each other out. So it's really just 2 here. That 2 stays. The 5s cancel out. We have minus 2 equal to 0. And this is true. 2 minus 2 does equal 0. And that's our solution. Well, at least we know, we're not done yet. At least we know that that point is on that line. 5, 2 is a point on that line. But it doesn't mean anything if it's not on both lines, right? Because like I pointed out before, there are lots of points on these lines, but the only one that matters is the point that's on both. So we need to check to see if 5, 2 is on the second line as well. So we're going to plug it in. We have 3 times x, which x is 5, and then minus y. 2 is y, and that's equal to 13. So we're going to check. 3 times 5 is 15, minus 2 equal to 13. 15 minus 2 does indeed equal 13. This is true. So it's 5, 2 is on the first line, and it's on the second line. So if that point is on both lines, then that means that is a solution, that yes, it's a solution, okay? Now, I'm going to have to do the work for the other ones on the other side a little bit. So I'm going to put B. I'm going to change my color. I'm going to use a different color. Let's use red. I'm going to do it over here. Okay, so now I'm checking to see if this point is on these lines. So I have x is negative 2, y is positive 2, and we're going to plug it in and see what happens. So the first equation, we have x, which x is negative 2, plus 3 times y, y is positive 2, equal to 4. So when I work this out, that's negative 2 plus 6 equal to 4. And that's true. Negative 2 plus 6 is equal to 4. That's 4 equal to 4. So negative 2, 2 is on that first line. But it's meaningless if it's not on the second one. So we need to see if it's also on the second line as well. So we have to plug it into the other equation too. It's on the first line, but it has to be on both. So let's check the second one. Negative x. X is negative 2. So notice there's two negatives here. I've got the negative from the x, and I got the negative from the 2. So I've got both of them. Negative, negative 2. Plus y. Y is positive 2. Equals 2. So remember, this is the second equation I'm doing right now. So negative, negative 2 becomes positive 2. And that's positive 2 plus 2 equal to 2. Now that's not true, right? That's 4 equals 2. That's false. That doesn't work. So that point is not on that line. It's on the first line, but it's not on the second. So that doesn't mean anything, right? Then it's not where they intersect. Because you can have that point on one of the lines, but if it's not on the other line, it's not where they intersect. So it's not the solution. So that is not a solution. All right, now we're going to try this last one. I'll pick a different color as well, just so it stands out. Let's do purple. Okay, so the last one we have, x is 1, y is 3, and we're going to plug it in. So that'll be 2 times x, which is 2 times 1, plus y, which is 3, and this equals 5. So we'll see if that works. That's going to be 2 plus 3 equal to 5. Now that's true. Let's check the other equation as well. We have negative 2 times x, which is 1, plus y, which is 3, equal to 1. So that's negative 2 plus 3 equal to 1, and that is also true. So that point is on both lines, so that point is a solution. Yes, it's a solution. Okay, now I'm not going to have enough room to keep all of these unless I write really, well, if I write really small, I might, or I'll zoom in a lot. All right. So what we're doing here, rearranging equations, is we're trying to set up each equation so that it's y equals mx plus b. Okay, we're trying to solve for y. Now, we're not trying to get y as a number. We're just trying to get y by itself, because if y is by itself, right, then all the other stuff is on the other side, y equals mx plus b. That's our goal, is to write an equation that's in this format. So looking at A, we have 2y equal to 3x. Ooh, hold on a second. Okay, we have 2y equal to 3x plus 6. So we want the y by itself, right? But it's got that 2 on it. So it's close, but we just got to get rid of this 2. Then the y is by itself. Since that's 2 times y, the only way to get rid of it is dividing by 2. 2 divided by 2 is 1 and cancels out, so that'll just leave us with y. But we have to divide everything by 2. So I'm going to divide both of the other things on the other side by 2 as well. So what that leaves me is positive y all by itself equal to, I've got a fraction here. 3 can't be divided by 2 evenly, so it's okay to just leave it as 3 over 2. There's no harm in that. In fact, we actually prefer to leave it as a fraction. Don't change it to a decimal. That's going to make things harder for us when we graph. Leave it as a fraction. So it's 3 over 2x plus 6 divided by 2, which is 3. And that's perfect. That's our answer. That's exactly how we want it. So all we had to do was divide by 2, and we were done. We solved it. We have y equals mx plus b. We have our answer. Now, b. For b, the second one, we have to get rid of this negative. Now, think of this negative as a negative 1. It's negative 1 times y. It's very similar to 2 times y. So, because it's negative 1 times y, right, we can get rid of it if we divide by negative 1. Dividing by negative 1 cancels that out, so the y is by itself. Now divide the other side by negative 1. 4 divided by negative 1 is negative 4x. And negative 5 divided by negative 1 becomes a positive 5. So there's our answer. So all we did was divide by negative 1. So if you ever see that, if you ever see negative y like that, just know that that means you need to divide by negative 1. Okay? All right, C. Again, we need the y by itself, so we need to get rid of plus 10. Well, that's a pretty simple one. We just need to subtract 10 to cancel it out, so we'll subtract 10 over here. So since the 10's gone, the y is going to be by itself, and it's going to equal these. Now, these are not like terms. These cannot be combined. The negative 2x cannot be combined with negative 10 because the negative 10 doesn't have an x on it. They're not like terms. They cannot be combined. So we just write it out as we have it. We have negative 2x, right? That's there, and then we're subtracting 10, so minus 10. That's exactly what we want our answer to look like. That's exactly what our answer is. Y equals mx plus b. Y equals negative 2x minus 10. And then the fourth one, it's very similar to the first one. We have 2 times y. We need to get rid of 2, so we're going to divide by 2. Actually, it is the same as the first one because I didn't update this slide. That's okay. I'm going to skip it since it's the exact same problem as the first one. I forgot to change that in the editing, but it's all right. Need this one to load. Okay. So we'll go ahead over here and do these for E. Now, these are 2-step problems. So it's like the last ones, but double the amount of work, right? We have to do 2 things instead of just 1 thing. So remember, we're trying to solve for y, okay? We're trying to solve for y. So to get that y by itself, we need to get rid of that 2 that's next to y, and we need to get rid of the 2x as well. Rule of thumb is save the y term for last. We can't get rid of that 2 until the last step. So we have to save that stuff for last, meaning we'll have to get rid of this part first. So the opposite of minus 2x is plus 2x. So we'll just add 2x to both sides. Now, what that's going to leave me is going to leave me with 2y on the left equal to 8 plus 2x. Now, you can write it as 8 plus 2x if you want, but I'm going to write it as 2x plus 8 instead because that looks more familiar to the mx plus b thing than the other way around. So you can do it however you want, but I'm just saying you might want to get in the habit of just leaving it in this format instead. So now we just got to get rid of the other 2 that's on y. So since it's 2 times y, we'll just divide that by 2. Dividing everything by 2 leaves you with y equals, so 2 divided by 2 is just 1x, and 8 divided by 2 is 4. So that is our answer. Y equals 1x, or x plus 4. Now for f, we need to we need to do two things as well. So again, don't worry about that negative on the y until last, okay? Don't worry about the y term until later. Let's get rid of the minus 5 first. So the opposite of minus 5 would be adding 5, so we'll do plus 5 and plus 5. Right, that cancels out that, so it's still negative y, but it's equal to x plus 5. All right, so just like we did in the second problem, I believe, we had a negative 1y, so we divide by negative 1. Anytime you have a negative y, you can just get rid of it by dividing out negative 1. So this leaves us with a negative 1x, or negative x, and 5 divided by negative 1 is negative 5. So now g, we'll go ahead and we'll solve this. Same idea as the last couple. We'll save the y term for last, so we'll get rid of the x term first. So we'll subtract 3x. So that gets rid of 3x. We get 3y is equal to 12 minus 3x. But like I said, you can write 12 minus 3x if you want, but it's probably better if we get in the habit of having the x term first. So negative 3x plus 12. It's negative 3x because it is a minus 3x. And it's plus 12 because it was a positive 12. So I'm going to write it like that again because it looks more familiar to the mx plus b. It looks better than the 12 minus 3x would. Okay, so now I just got to get rid of the 3 on the y. So we'll divide by 3, cancel out. We'll have y equal to, well, I got to divide these by 3 as well. So negative 3 divided by 3 is negative 1, so that's negative x. Negative 1x, that is, at least. And then 12 divided by 3 is 4, so negative x plus 4. And then our last problem here. The last problem, negative 4y plus 16 equals negative 2x. So save the y term for later. Let's get rid of the 16. Subtract 16. So this is negative 4y equal to negative 2x minus 16. Remember, you can't combine those because they're not like terms. You have to leave them separate. Negative 2x minus 16. Now we'll get rid of negative 4. It's negative 4 times y, so we'll divide by negative 4. That'll cancel it out. Divide everything by negative 4. So this leaves us with y equal to, okay, now what's negative 2 divided by negative 4? It's a fraction, and I already know the negatives will cancel because the negative divided by negative makes it positive. But we can reduce that fraction 2 over 4 to 1/2. Okay, 1/2 x. And it's positive 1/2 x because, like I said, the two negatives there are going to cancel out. Same thing on the last one, actually. Negative 16 divided by negative 4. Those negatives also cancel. And 16 divided by 4 is 4. So it would be a positive 4. And that's all the work that we really did today on Monday. I wanted to do the next slide down, but we didn't get time to. And I didn't want too many people to miss too many things. So we will do this stuff tomorrow. I'll see you guys there.